So on the front side of this worksheet, we have the steps on how to graph parabolas. Step one is to do what? Find what? It's that special V word. What is it? Vertex. That's right, vertex. And ladies and gentlemen, the vertex is just a point somewhere on this graph, but it's the most important coordinate. It's either going to be the highest point or the lowest point of your U-shaped curve. It's going to be that point that is dead center of the parabola, right? Where your axis of symmetry goes through. How do we find that vertex? We use the formula x equals negative b over 2a. Once again, x equals negative b over 2a. So for the sake of saving time, I kind of set this up before you guys even got here. I wrote down v, I put a coordinate right here. This isn't a sad face, it's a coordinate, right? So your vertex is going to be this coordinate. We know that the coordinate is an x and y value, and we know that the formula is x equals negative b over 2a. Let me write that down. X equals negative b over 2 times a. Now, how do we use this formula, x equals negative b over 2a? You write it as negative parenthesis over 2 times parenthesis. So now we're just going to plug in our b value right here and our a value right here. Now, if you don't know where you get the b and the a value from, remember your standard form quadratic trinomial is a, b, and c, right? So what's our b value? Negative 2. This is the b value. What's the a value? 1. So let's plug in a negative 2 for b and a 1 for a. Negative 2 right here and a 1 right there. So if I work this out, up on top, the negative negative changes to positive, and that'll be a positive 2. And 2 times 1, well, that's just 2. So I have 2 over 2, which is 1, correct? Now that is the x value. Notice it says x equals 1. So I'm going to take this 1 and I'm going to put it right there because that's my x value of my vertex. Again, the vertex is just a coordinate, an x and a y value, and we just said that the x value is 1. Now, whenever you have the x value of any equation and you want the y value, how do we find it? We plug it back in, right? So notice that I already set that up just to save some time. So I'm going to take the 1 that I got from my x, and I'm going to plug it in right there into that x, and I'm going to plug it in right there into that x. So to do that, you're going to have to replace the x's with parentheses first. And that's what I did over here. These are parentheses instead of the x's. So it's the same exact quadratic trinomial equation, but instead of x's, I have parentheses. And let me plug in the 1 right into those parentheses. Is everybody with me? Okay, so now we're going to just do the math. Let me zoom in right here. We're going to do exponents first. 1 squared, that's just 1. And then how about negative 2 times 1? That's just negative 2. Then bring down the minus 1 at the end. So it's simply 1, take away 2, that's negative 1. Take away 1, that's negative 2 again. So my final answer is negative 2. And we're talking about the y value. Y equals negative 2. Now, what do I mean by y equals negative 2? I'm talking about the y value on the vertex. The y value on the vertex is negative 2. So, ladies and gentlemen, we have found the most important point, the vertex. Let's graph the most important point, the vertex. 1, negative 2 on our graph. 1 on the x, negative 2. That's going to be right there. That's my vertex. Now, why is it the most important point? Because through the vertex is the axis of symmetry. And on previous videos, I've graphed that as a green dotted line. I want to keep that going. So there's my axis of symmetry right through that vertex. Okay. If I wanted the equation, let's say they asked me for the equation of the axis of symmetry, that would be the equation x equals 1. It's the same thing as your x value of your vertex. That's the line of the axis of symmetry. And that axis of symmetry provides a reflection on both sides of that line. So we need some more coordinates. How do we find more coordinates to any equation? X and Y table, that's right. So that's where I go to the left right here, and I'm going to draw a quick XY table. And then I need to plug in some values. What would the easiest number to plug in be? The easiest number to plug in into this x and that x is what? Even easier than 1. 0. 0 is the easiest to plug in. If I do the input 0, I mean, think about it. We could do that in our head. Plug in a 0 right there, a 0 right there. It's going to be 0 squared. It's going to be 0 right there because 2 times 0 is 0. So 0 take away 0 is 0. And then 0 take away 1 is negative 1. As a matter of fact, whenever you have an input of 0, your output will always be the C value, which in this case is negative 1, right? So that was super easy, right? That's a coordinate, 0, negative 1. Let's graph it. 0 on the x, negative 1 on the y. Let's put a dot right there. And that actually is the y-intercept. That's where our U-shaped curve crosses the y-axis. Obviously, it touches that y-axis right there. But we need some more points, right? Now, since I already have a point on this side, I would like another point somewhere up here, right? So what number would be nice to plug in for x if I wanted another point up here? Negative 1 would be great. So let's plug in negative 1, because you see negative 1, here's 0 on the x, negative 1 on the x is right here. So obviously it'll give us a coordinate somewhere right here, depending on what our output is. The output's the y value. So let's plug in negative 1 right there and right there. I'm going to have to zoom in a lot and plug in negative 1. Check it out. There's my equation. Let me plug in negative 1 right in there into the parentheses. So negative 1 squared, that's positive 1. Negative 2 times negative 1, that's positive 2. So I really have the positive 1 plus 2 minus 1. So my answer will be what? 2. Okay, so my y value is 2. And that's another coordinate, negative 1, 2. So if I go to the coordinate on the graph, negative 1, 2, negative 1, 1, 2, I get that coordinate right there. And technically, I'm done. Why? Because the axis of symmetry provides a reflection on both sides. So I could take this first point and just map it over to the other side. I could take this other point and map it over to the other side. It's as easy as counting how far this point is from the axis of symmetry, which it's only 1 unit away. So go 1 unit this way and put a dot right there. And the other one is 1, 2 units away from the axis of symmetry. Again, 1, 2. So just go 2 in the other direction, 1, 2, and you will have reflected it to the other side. So let's put a dot right here. And notice, we already have enough dots that'll give us a perfect U-shaped curve. That's good enough. Let's just draw a line right through them. And don't forget to put the arrows up here at the end because it does continue to go up forever and out forever technically. Okay. And that's it. Let's move on to the next one. So step 1 is to find the vertex. Once again, just to save some time, I already put the v in the parentheses right here for the coordinate. I even wrote the formula to get the x value of the vertex, negative b over 2a. I even wrote that formula without the letters with parentheses. And then I even went back and I wrote the original equation without the variables with parentheses. So let's find out what the x value of our vertex is going to be, and then we'll find out the y value of our vertex. So let's plug in the b and the a. Now what is the b right here? If it were in standard form, the a value is negative 1, the b value is what? Don't say 3. 0, right? There is no b value. The c value is 3, but there is no b value. So the b value is actually 0. So if we zoom in right here, and we say that the b value is 0, we said that the a value is negative 1, correct? And now let's work this out. That's going to be 0 over, even though it's negative, it's still 0 over negative 2. And it doesn't matter, 0 divided by anything, right, is 0. If you have nothing and you divide it by 2, it's still going to be 0. So our x value of our vertex is 0. And remember the previous question, it said, or we mentioned that when you do an input of 0, your output will simply be the c value at the very end. When you input 0 right here, 0 squared with a minus in front is still going to be 0, and 0 plus 3 will be 3. Now, of course, you could show your work if you want. That's why I set this up down here. Notice there's my original equation. Here's my new equation with parentheses instead of the x, and we're plugging in 0. Obviously, you're going to have 0 squared, which is still 0, negative 0, which is still 0, and 0 plus 3 is the 3 that we got as an answer for y. So that's our vertex. let's graph it. 0, 3. 0 on the x, 3 on the y. There it is. That is the most important point. If you wanted to, you could draw an axis of symmetry right through it. It's kind of unnecessary because it's pretty clear that it's the y-axis itself. I want to draw it anyway. Dotted line right through it. So there's my xy table. Normally I would say, what's the easiest number to plug in? 0, right? That's the easiest number, but we already plugged it in. That was part of the vertex. The vertex x value was 0, so it would be pointless to plug in 0 again. We want to plug in other numbers. So what number do you think is easy to plug in besides 0? 1's always easy, so let's go ahead and just put a 1 right here for the input. And if I did plug in a 1 right here, I could even do this in my head, right? Let me do this at least. Let me rewrite it like that. And then let's think, if I plug in a 1 right here, what's 1 squared? 1. With the minus in front, it'll be a negative 1. And negative 1 plus 3, what's negative 1 plus 3? Positive 2, right? Negative 1 plus 3 is 2. So ladies and gentlemen, we have another coordinate, 1, 2. Let's graph it. 1, 2 is right here. And let's get another point. So what other number should we plug in? Especially if we already have another point on the right side of the axis of symmetry. I would like another value over here somewhere on the right side of the axis of symmetry. So what number do you think would be a good idea to plug in? 2, right? We already plugged in 0 on the vertex. We plugged in 1 right now and we got out of 2. The next number to plug in would be 2. That way we could probably get a point right here or right here, maybe down here, I don't know. But this last point will be the final point that we need. So let's plug in 2 for x. So if I zoom in again and plug in 2 right there, this time I am going to draw the 2 right there. What is 2 squared? 4. And with the negative in front, that'll be a negative 4. And then with the plus 3, what's negative 4 plus 3? Negative 1. So the output is negative 1. So there's a negative 1 right here. And that's my next point. And technically we'll be done after that because we're just going to map over the coordinates. So let's go to the coordinate 2, negative 1. 2 on the x, negative 1. Put a dot right here. And now we could just map over the coordinates. So what do I mean by map over? From the axis of symmetry, it's 1 unit right here. So go 1 unit this way and put a dot right there. Now the next one is 2 units away. Check it out. 1 unit, 2 units. So we're going to count 1 unit, 2 units and put a dot right here. And as you can see, that's already enough coordinates to draw your perfect U-shaped curve that's opening down right through those dots. And we have graphed it. Okay? Now, yes, you could plug in more points if you want. Like if I were to plug in a 3 for x, that means that I'd be over here 3 on the x and I'd get a coordinate somewhere down here. Right? Somewhere down here. You don't have to, but you could if you wanted to. You could plug in as many points as you want, actually. But that's already good enough to demonstrate that you know how to graph. Instead of continuing on, let's take a look at both of these graphs that we already have graphed. And let's talk about domain and range. All right? So domain are your x values. So your domain are your x values. And what we're going to do is write it as x. And then you have to state what your x values are on your parabola. Okay? So, like if I take a look at these coordinates, there is the x value of 0 because this coordinate has 0, negative 1. It has the x value of negative 1. It has the x value of 1, of 2, of 3. And technically, you're going to have as many x values as you want. And it does go to the left forever, right? It does exist at negative 5, but it's going to be way up there off this graph. But it does exist because it keeps going up and out forever. So my domain for this graph up here is going to be x equals all real numbers. Why? Because it goes to the left and to the right forever. Okay? The range are your y values. And as you can see, this whole graph, it has the lowest point at negative 2. Everything else is above. So your y values have to be greater than or equal to negative 2.